everyone!
I'm Norimanina.
And I'm Fatihanani.
So today we are going to talk about
Thermodynamics! One of the main goals of the thermodynamic is to describe about the transfer of energy, work and heat.
Heat is converted to work and work is converted to heat. Together, the work and the heat transfer into and out of the system, represent the change in its internal energy.
Now, let's look at the thermodynamic system. What is thermodynamic system? Thermodynamic system can be defined as any part of universe under consideration or observation for the purpose of study and analysis.
The internal energy of U of a closed system is equal to Q, the heat transfer to the system, minus W, which is the work done on the system. It's important to remember when we talk about changes in internal energy, if heat transfer into the system, Q is positive, and if heat is transferred out of system, Q is negative. If work is done on the system, W is negative, and if work done by the system, W is positive. Thermodynamic system can be categorized as open system, closed and isolated system. Let us discuss all the system one by one.
First is an open system. The system in which transfer of mass and energy take place is known as open system. Here, in the diagram of open system, we can clearly see that both of mass and energy can come in and go out of the system. Here, the volume of the system does not change. Therefore, an open system is also known as controlled volume system. A common example of open system is a boiling water in an open utensil.
Next is closed system. The system in which only transfer on energy take place and mass remain constant is known as closed system. For example, in one piston cylinder arrangement, cylinder contain gas. If we supply heat to the cylinder, the volume of gas will increase and piston will move in the upward direction. In this case, transfer of energy take place but mass of air remain constant.
Here, in the diagram of closed system, we can clearly see that only energy is able to come in and go out of the system by passing to the wall of the system. In closed system, the mass remain constant. Therefore, it is known as controlled mass system. For example, cooking of food in a pressure cooker is a good example of closed system.
The next system is the isolated system, the system which will not be influenced by its surrounding, which no transfer of mass or energy take place across the boundary of a system. A common example of isolated system is a thermoflask in which both mass and energy remain within the wall of flask.
Let's summarize what we have learned so far in this video. Here, we see the energy and mass involved in each type of the system. In open system, both energy and mass flow across the boundaries of the system. In closed system, only energy is allowed to cross the boundaries of the system, but mass is not allowed. In isolated system, neither energy nor mass is allowed to cross the boundaries of the system.
In second law, it says that heat will spontaneously flow from something hotter to something colder, but it won't flow from something colder to something hotter. And that is because the entropy. The entropy is often described as the inherent of disorder of a system. The more disordered the system, the higher the entropy.
For example, with all the molecules randomly bouncing around, as a higher entropy in the solid, the molecule is neatly arranged.
In thermodynamics, entropy is related to heat flow because when heat flow between the system, their entropy increase. Heat spontaneously flow from warmer system to cooler ones because that lead to an increase in entropy.
Say you put the water in the freezer to make ice, for example. The entropy of the water goes down as it freezes. Meanwhile, your freezer is putting out heat as it works to keep itself cool inside, and the heat from your freezer is increasing the entropy of the kitchen more than the entropy of the ice is decreasing. Therefore, there is an increase of entropy of universe.